Hi, ignore my bad handwriting, but the concept I'm going to give you is very important. Instruction codes, this is the correct representation of how we define the bits in instruction code, right? So it is divided into two parts, operation code, opcode, and address, right? So 0 to 11, if it's a 16-bit instruction code, 0 to 11 are given to the address bits, and 12 to 15 is given to the opcode. Now, why have we structured the bits in this way? I'm going to tell you later. Alright, this is instruction format we're going to go with. For 6 bits, let's say I have 6 bits, right? So how many operations can I perform with them? The number of operations can be 2 raised to the power 6, 64 operations. Let's say I have 12 bits, so I would have 2 raised to the power 12, whatever the answer is. Number of operations will be equal to that. Okay. Similarly, this is the formula. 2 raised to the power n would be the number of bits, and this will equal the number of operations we're going to have. So this is going to be the minimum bits we need for the number of operations. That can be any number. For example, 12, 16, 32, any. Alright, let's look at an example. We have a memory, and the size of the memory is 4096 into, or let's say by 16 bit. Alright, this means that there are going to be 4096 words, and each word is going to be of 16 bit. Okay. So how do we tell that how many bits would be required in our instruction format if the words are 4096? There's a simple formula. 2 raised to the power x would be the number of bits we're going to assign for our this representation of 4096 words. So 2 raised to the power 12 is equal to 4096. Therefore, we're going to give 0 till 11 total 12 bits to the address of these words. Okay. Then how do we know that how many operations are going to be performed? Well, we just thought of that over here. So for 16-bit, the answer is 2 raised to the power 4 equals 16. So we're going to need 4 bits for our opcode. So I'm just going to write over here. 0 to 11 is for the address bits, 12 till 15, 12, 13, 14, 15, 4 bits for the opcode. This is how we designed our instruction format over here. Okay. Now there are parts to the one more part to the opcode, and that is the addressing modes. Like how do we know that where our component is? Like let's say the address of the register is given over here, right? So how do we know which register is this? If it's like a number, no register, it's just an immediate value, right? If I'm giving you the address of a register, that's going to be the direct call. We're going to call that a direct address. If I'm going to give you the address of the direct register of which I need to like tweak the value of or to perform the operation on, I'm just going to give the address of the register, and that is going to be called direct address. If I enter over here an address of a register, let's say 135, and that register holds the value of another operand, and that is my actual operand I need to perform the operation on. This is called indirect addressing. Alright, so the address is going to hold another address in which the content is going to be the address of the actual register or value I need to perform the operation on. So I've got 3 addressing modes over here. Immediate operand, let's say the value of 8, just writing simply 8 or 9 of any value I want to add. That is going to be placed in address bits. So address are going to be replaced by the immediate operand. But in case of direct address, I'm going to provide the direct address. Like I told you, the address of the direct register the operand is in. For example, let's say I have this instruction address. I've got 0 bit over here. I've defined direct addressing with 0 bit. I'm going to perform addition. So over here we gave 4 bits for the opcode, 1 bit for direct addressing, 3 bits left. That I'm going to just write the instruction for addition. Okay. Actually, this is the opcode. It could be 0, 1, 1, whatever my logic is. Then I'm giving the address. This is the address, right? And I'm giving the address of the register in which the operand is placed in. I go to this address and I find the operand. I perform addition on this operand. Okay. If, and this is called effective address. If the situation is a little bit different, for example, this is my instruction. I've the MSB most significant bit. I've put it 1. 1 represents indirect addressing, right? I have given the instruction to add, and I've put an address over here 135. Now since this is 1, my computer knows that 135. I'm going to go on 135. I'm going to take another address. I'm going to go on 1350, and there I will find my operand. So it's basically like a packaging. I've put the address. I go to that address. I uncover another address, and that is going to be my actual place where operand is. Right? This is called indirect addressing. That is going to be like directed towards the accumulator, and the operation is going to be performed. So this is it for instruction codes. Follow for more.